Hello student, today we are going to start BGAM method algorithm and problems on a BGAM method. First of all, we will see algorithm of a BGAM method, means all the steps of BGAM method. So what is the first step? Write the given LPP into standard form by introducing slab, surplus or artificial variable whenever the necessary in the given constraint. We know that if the constraint involves the greater than equal to sign, in order to convert that inequality into equations, we have to introduce surplus variable with a artificial variable. Okay. Then if the constraint involves the equal to sign, then we have to add only artificial variable. Okay. So similarly, then we will assign a very high penalty, or we can say the large price, let us we say capital M, to these variables in the objective function. Okay, such a high penalty, or we can say that large price, will be denoted as a minus M for the maximization problem. And if the problem is minimization, then we will assign a high penalty, that is plus M. So here capital M is always strictly greater than 0. Then third step will be, so in similar manner we will apply the simplex method to solve the given LPP. At the end there may be arises two cases. So first case will be, at least one artificial variable is present in the basis with a 0 value. In such a case, the current optimum basic feasible solution is degenerate. Second case will be, at least one artificial variable is present in the basis with a positive value. So in such a case, the given LPP does not possess an optimum basic feasible solution, and that given problem is said to be a pseudo optimum basic feasible solution. So at the final there may be the two possibilities. Okay, now we will see the problems on a BGAM method. What is the problem? Given that maximum z equal to 3x1 plus 2x2 subject to constraint 2x1 plus x2 less than equal to 2, and second constant is 3x1 plus 4x2 greater than equal to 12, x1 x2 greater than equal to 0. So this is the given problem. So we have to solve this problem by using BGAM method. Okay, so what is the solution? We know that the given LPP is a maximization time. Okay, so here given LPP in the form of maximization. Okay, so introducing slack variable x3, because here is a less than sign, x3 greater than equal to 0, surplus variable x4 greater than equal to 0, and artificial variable a1, because here is a greater than equal to sign, so therefore we will introduce here surplus variable x4 with artificial variable a1 into the given constraint and convert this inequality into the equations as follows. Okay, so what we will get? So first constraint will convert 2x1 plus x2, this slack variable x3 equal to 2, and second constraint will be 3x1 plus 4x2 minus x4 plus a1 equal to 12. So this is x4 is a surplus variable and a1 is a artificial variable. Okay, so here x1, x2, x3, x4 and a1 always greater than equal to 0. So let us consider equation number 1. Okay, so this is the equation number 1. Now for this equation number 1, we will construct the new modified objective function for this. So which is given as maximum z equal to 3x1 plus 2x2 plus 0x3 plus 0x4 minus capital M a1 according to our algorithm. Here we will assign high penalty, that is minus M, because the problem is the maximization time. So therefore we will assign here maximum large penalty, that is minus M a1. Okay, so here C1 is 3, C2 is 2, and C3 C4 is 0, C5 is minus M. Okay, Now we will find out the initial basic feasible solution. So put x1, x2 and x4 equal to 0 in equation number 1. Okay. So here we will put the values of x1, x2 and x4 equal to 0. We get x3 equal to 2 from this equation and a1 equal to 12 from this equation. Okay. So which is called as a starting basic feasible solution. x3 equal to 2 and a1 equal to 2. Now we will construct the first simplex table. Now we will construct first simplex table. So what is the first column? YB, second column CB, third is XB, Y1, Y2, Y3, Y4, and last column is A1. Okay. So YB means basic variable as well as non-basic variable. So Y3 and A1. Okay. CB is associated cost, that is C3 is 0 and C5 is minus M according to this. Okay. XB means RHS side of the constant, that is 2 and 12. 2, 1, 1, 0, 0, 3, 4, 0, minus 1, 1 from equation number 1. That means we can say that the coefficient of x can be written in this way. Okay. Then find out Z CBXB. So CBXB means 0 into 2, that is 0, plus minus M into 2, that is minus 12M. Then we will find out CJ, ZJ, ZJ minus CJ. CJ means C1, C2, C3, C4, C5. Already we have found out here. Then ZJ. ZJ means CB into YJ. CB into YJ. Okay. 0 into 2, that is 0, minus 3 into M, that is minus 3M. Then here again 0 into CB into Y2. 0 into 1, 0, minus 4 into 4, that is minus 4. So according to this, 0 into 0, then minus M into 0, that is 0. So in this way we will find out the ZJ values. Then ZJ minus CJ. Okay, so take the ZJ minus CJ, minus 3M, minus 3, minus 4M, minus 2, 0 minus 0, here M minus 0, that is M, and minus M plus M will get cancelled, 0. Okay. So if you observe from this given table, here some values of ZJ minus is less than 0, that means negative. Okay. So this table will not give the optimum solution. So to find out the optimum solution, we will construct the next simplex table. So for that we have to find out incoming vector, outgoing vector and key element. So here y2 is incoming vector, because here minus 4m minus 2 is a large negative value, most negative value. Okay, so here minus 4m is a most negative value, so corresponding vector y2 will lose the basis, or we can say that y2 is a incoming vector, then by computing then we will find out the outgoing vector by computing minimum ratio, that is xb divided by incoming vector. Incoming vector is y2, so it will written as 2 divided by 1, that is 2, then 12 divided by 4, that is 3. Okay, so here 2 is a minimum ratio, the corresponding vector is y3 will use the basis, that means we can say that y3 is a outgoing vector. So here y3 is a outgoing vector. Now we will find out incoming vector. Incoming vector means the cross section of incoming vector and outgoing vector. So this is the cross section of the, or we can say that cross element of incoming vector and outgoing vector. That element is called as a key element. So here 1 is a key element. Now we will construct the second simplex table. So YB, CB, XB, Y1, Y2, Y3, Y4, A1 as it is. Now what will be the change here? Here will be change, y3 will leave the basis and y2 take the position of y3. Okay, so in place of y3 we will write y2. Okay, then y2 c2 means 2, then a1 as it is, a1 minus m as it is. Okay, now Now we will find out this element. Okay, now we will find out this element. Okay, so how will you find out this element? So dividing this key element to this key row. So 2 divided by 1, that is 2, 2 divided by 1, that is 2, 1 divided by 1, that is 1. So here write down the 0. Okay, then 1 divided by 1, that is 1, 0 divided by 1, that is 0, 0 divided by 1, that is 0. Okay, then we will find out these elements. That means 4 minus 5 minus 4 minus 1, 1. Okay, we know that the technique to find out that element, that is 12 cross section of these two number divided by 1, that is 12 minus 8, that is 4. Then we will find out this element, that means this minus 5 element, that is 3 cross section of this two number divided by element, 3 minus 8, that is minus 5. Then 0, this will there is no find out the there is no need to find out this 0. Okay, then we will find out this minus 4. How will you find out minus 4? 0 cross section of this two number divided by key element. Okay, it means 0 minus 4 divided by 1, that is minus 4. So in this way we can find out this element, that is minus 1 cross section of this two number divided by key element, that is minus 1. So last is 1, that means 1 cross section of 4 into 0 divided by key element, that is 1. So in this way we can find out all the elements in this table. Then find out Z, CB into XB. CB into XB, 2 into 2, that is 4 minus 4M, that is 4 minus 4M. CJ, 3, 2, 0, 0 minus M according to the objective function. Then ZJ means CB into YJ. CB into YJ means 2 into 2, 4 minus M into minus M, that is plus M. 4 plus 5M. Then Z2. So again 2 into 2, that is 2 minus M into 0, that is 0. That means 2. So in this way we can find out Z1, Z2, Z3, Z4 and Z5. Then find out Zj minus Cj. Zj minus Cj. So here Zj minus Cj is 1 plus 4M, 0, 2 plus 4M, M and 0. Okay. So here all the values of Zj minus Cj is greater than equal to 0. Okay. So in this table we will get the optimum solution, because here all the values of Zj minus Cj is greater than equal to 0. Okay. But we know that case number 1 and case number 2. Okay. So here artificial variable is present at the basis with positive value. Okay. Here artificial variable is present at a positive value. We know that coefficient of the M in the Zj minus Cj is non-negative and artificial variable is present in the basis positive level. So in this given LP does not possess any feasible solution. Okay. So according to case number, which case number? Case number 2. At least one artificial variable is present in the basis with positive value. So here A1 is a artificial variable with positive value, that is 4 is present. That means here case number 2 will apply. Okay. So according to case number 2 we can say that here A1 is a artificial variable present in the basis at a positive value 4. So therefore according to the case number 2, a given LPV does not possess any feasible solution. So this is the first problem on a big M method.